All right, now that we are recording, so this is where we left off yesterday. We counted up all the frequency. We had a tally mark right here. I'm not going to put all the tallies, but this is where we had our tallies to kind of help us figure out our frequency. A cumulative frequency literally just means we're going to add them as we go. We saw this on our first example. So what would be the first cumulative frequency after 11? 16, and you just keep going through it. So 16 plus 4. 20 plus 4. Go ahead. Yeah, so 11 was the first one. And so then 11 plus 5 gave us 16. So at this point, what this represents is 16 of these. I don't even remember what was the topic even about? Oh, coaches with salaries. So 16 of the coaches have $319,000 or less. And then we keep kind of going through that process. So then 20 have $409,000 salary or less. 24 has $499,000 or less, and so on and so on. So it's adding them all up. So then 24 plus 24, 28 plus 0, 28 plus 1, 29 plus 1, 30, which makes sense. All right. So the total here, well, we don't have, that is the total. All right, so then it says a relative frequency as a decimal. So what we'll do is we have 30. So to figure out all these results, they went 11 divided by 30. That's how they got to 0.37. So we're going to do the same process. We're going to do 5 divided by 30. And what's that as a decimal? No. Okay, what's that? Nope. You're thinking 1/8 though, which would be 0.125. Close. So we'll say 0.17. And then we'll go here. This is 4/30. What would that be? I have blue ones over here. All for you. That you can use. Okay. Okay. Good. So we'll say 0.13. 0.13 is, yeah. And then these are real easy because then 4/30, we just did the math, was 0.13. 4 out of 30 again would be 0.13. That's not 13. Total people in the group. We had 30 top salaries, or we had, well, I don't know if it was top salaries, but 30 people, colleges and coaches at the university in the United States. And then this one would be 0 out of 30. What's this one as a decimal? Good. And because now statistical purposes, you would want to keep it as 0.00 because you had 2 place values for all the rest of them as well. What is 1/30? It'd be 0.03. And I was about to say, if you just did your math earlier when you found out how much it was for each one, that you got there too. And so, of course, again, 1/30 would again go right back to 0.03 as well. Now, again, one thing you do want to make sure is all of these decimals are almost like percentages need to add up to what? 1. If you were doing percentages, it would need to add up to what? 100. Very good. Now, when we get into the cumulative relative frequency, it starts off the same where it's 11/30, but then we're going to add up each one corresponding. So this would actually be 16 out of 30 to represent 319 up. And you could literally add them up. So 0.37 plus 0.17 would be roughly. They went with 5.3, so I bet there was a decimal rounding something there. So we would want to probably check with calculators as well just to verify our math. And then this one would become 20/30, which we should know what that one is. 0.67, because that's like 2/3. Then we have 24 30ths, which would be 0.80. Very good. And then 28 over 30. And just adding up all of these numbers here. Very good. And then 28 over 30 again will be just 0.93. And then we get to 29 over 30, and that would give us what? It went with 0.98, but why? Was this a 5? No, it's a 3. Why did it go up to 0.98 versus 0.96? It must be a decimal thing. Maybe this was like 0.934, and then this became 0.34, which then added together would go up to 8, maybe? Question mark? I don't know. But I would check this actual calculation here to avoid any rounding errors that might have occurred in the first column. And then the hundredths place, yeah, because that's going to be your percentage as well. And then, of course, 30 out of 30 should always give us 1. So any questions making up a frequency distribution graph? Okay. So today we're going to talk about histograms, frequency polygons, and Ogives, or however you say that word. We will take an oral exam as well. If you do not pronounce it the way I pronounce it, then you'll be wrong. Always love that. And there's always going to be those college classes where a professor says that and you're like, that's wrong. But you remember it, so you take it on the test and just throw it out in the trash when you're done. It happens. I took a introduction to world religion. It was like the top 5 religions, my philosophy class I had to take. And there's like, not factual, but I'll remember it for the test, and then I'm just going to ignore the rest. Anyways, so we go 2 histograms, frequency, polygons, and Ogives. This objective 2 is going to represent data in frequency distribution graphically using histograms, frequency, polygons, and Ogives. So these are your 3 graphs that we talked about. There we go. Yeah, we're not crossing it out. We're just underlining it. All right. So it says when data are organized into a frequency distribution, the summary can present it in graphical form. And you've seen that before, even with pie graphs and stuff like that. The most commonly used graphs are histograms. Histograms that display data using no, there's a G there. Contiguous. Contiguous vertical bars. It is not considered a histogram if it is not vertical. They have to be vertical, right? We cannot have them horizontal. I think that gives them a different type of name. But these are basically what you would call your bar graphs when you saw them. Yeah, yeah. I'm sure it has a different name, but for it to be considered a histogram, it has to be vertical. Unless the class frequency is 0 of height, representing the frequency of the classes. Basically, what it says, if it's a frequency of 0, there'll be an absence of a bar because it's an absence of something. Right, but everything else around it would be vertical. All right, so a frequency polygon are graphs that display data using lines that connects points plotted at heights representing class frequency at the midpoints of classes. So you would look at the midpoints part, and these are basically what we call line graphs. And I'll show you some examples today on that. But to give you a rough estimate, you would have like all your little certain things here, and it'd be like here, here, here. So that right there would represent what we call a frequency polygon. Yes, because it represents the midpoint, not from the lower bound to the upper bound, like you would see on a histogram. They go from lower bound to upper bound for the frequency chart, for the classes at least. A cumulative frequency graph. This was the old name. The new name is now Ogives. This one is actually also a line graph, but it does the cumulative frequency. So this would be that cumulative frequency where instead I should get more graphs that look like this. Maybe not consistently going up the same, but it should progressively go up. Or it could plateau as well, but you shouldn't have Ogives going downward at any moment. Does that make sense? Because you're cumulative, you're adding them all up. So the numbers should either be staying the same or getting higher, right? All right. All right, so those are our three main ones that we're going to look at. Oh, good. But this is what we just filled out. Oh, I could have started with this graph. Oh, well, whatever. All right, so they want us to construct a histogram, a frequency polygon, and ogive for this frequency distribution, representing the salaries in hundreds, thousands of dollars of a sample of 30 colleges and universities. So we're going to take this chart that you've created and represent them in three different type of graphs. There we go. So there's all of our answers. Oh, I didn't see that. All right. So an example, is Jaws already built too? Oh, what sucks. I was going to build it with you. All right, so construct a histogram. We're going to draw the axis first. So your x-axis and your y-axis. The x-axis obviously is the horizontal axis. So just like in a coordinate plane. The y-axis is the vertical axis. Again, just like a coordinate plane. But then we're going to label. In statistics, you will get it wrong if you do not label your axis. We need to know how you're analyzing your data because it can be displayed differently. Majority of the time, though, your y-axis would represent your frequency, like how many times something happened, and your x-axis would represent your classes, whatever that category is. But you could technically reverse that on some of them. As long as it's labeled, it could still look like a bar graph or a histogram or something like that, right? But just as a forewarning, your it says it right here. Your horizontal axis will be your classes, and your vertical axis are your frequencies. All right, so for the main purpose, let's keep it like this because it just looks cleaner. But there are certain situations they can flip. All right, then step 3, using the frequencies as heights, then we're going to then just draw the vertical bars for each class. Questions on how to build it? So I know it's already built for you, but we're going to pretend it doesn't exist, and we're going to build it anyways, right on top of it. All right, so let's say this is what we have. So what we would do is when we look at our chart, we have, well, we can actually finish this off, right? Because there's some things that are missing. We have our axis built, as you can see, have our numbers. They don't have to go by the same numbers. And typically what you would see here, which it doesn't see, we have like a little squiggly line there to represent there's a gap in the graph. So you go from 0 to this, but it's not necessary if you don't want to, but you might see that on graphs where it just cuts out a part of the graph to go automatically where we want to look. It doesn't matter what you go by, but you do have to have the same width. So if I want to go by 2s, then this should be by 2s. I can't go 2, then 7, then 9, then 10, and then 15. It has to be consistent. So we look at our largest cumulative frequency, and we see that it is 11. So going by 2s is a smart idea unless you want it to make 11 ticks. That is fine too. You do not have to go by 2s. And here they actually all go up by 90 because we know that's how big our sample difference is. Notice that these are the midpoints. It's not always written like this. Sometimes you'll actually see it as the lower bound to whatever the upper bound is. So this one here could have been written as 140 to 229 instead of just doing the midpoint. Both of those would have been acceptables when it comes to histograms. After that point, once you've got that all labeled, then you just go up to where it was. So this one had 11. So you put a mark up there, and then you just make a box as such. You can fill it in if you like. Most people might just do these instead of having to shade it all together just to kind of give it color. Maybe you might do a little diagonal as well here to give it some more without having to color the whole thing. So that's completely up to you. When we get to a double histogram later on in the class, you would want to represent your two histograms that you're comparing to as two different colors or two different designs. So maybe you have one this way and then the other one's this way, or maybe you have one this way and then the other one has a double, but whatever different design to distinguish between them. And then we see that this is 5, so it'd be right there. And then this one is 4 all across the board. And then this one adds 0. So this would be an example where it's not a vertical bar, but it has 0 frequency. So it's just an absence of a vertical bar is what it represents. And then these both had 1. You also must give your graph a name. All right, biggest thing to do is just figure out what the topic is, and then that's what you would write. So in this one, it's college and university coaches' salaries. So must have, and then the other part that's missing is we didn't label our axis. So what would this axis here be called? So this would be your frequencies. What would this one be? I would almost call this midpoint salaries. Or you could go a little bit further and say midpoint coaches' salaries. And then this is very specific now. In, was it 100 thousandths is what it wanted in? Where's the directions? Well, I guess I didn't have them. What did it say in y'all's? Okay. Okay, so we'll do thousands. Just so that the reader then knows what its answers will be in. So they would say, all right, 1,000 times this would give you, $184,500,000. Questions on that? So we were able to do a little bit with it, even though it's already kind of done. Any other questions on building a histogram? So labeling matters. Keeping your units consistent matters. Making sure you have your histograms. I will say I've always been confused on this between the difference of being spaced versus not spaced, because you might see some that look like this. To my knowledge, this would not be a histogram. They need to be touching and vertical, but by definition, it didn't specify that. But for the sake of making sure that we are correct, let's make sure ours are touching. Because for us, a gap to me represents an absence of a vertical axis, which means there's 0 in that class. Any questions on histograms? All righty. Taking the same data, let's build a frequency polygon. So you can see it. So to construct a frequency polygon, the first thing you want to do is find the midpoint of each class, which we did in our table. So notice you'll always have to build this table before you can build the next thing. And then step 2, just like in a histogram, you want to label the X and Y axis. The X axis is still going to be labeled with class midpoints. So with histograms, you can have your lower and upper, but with these line graphs, basically, you want to start with your midpoints there. And basically what it should look like, I wish I could hide that, but if this is your histogram, or whatever it was, I done forgot it now. This is technically what the line graph is doing. So they kind of all correlate. So you should be able to put a line graph right on top of a histogram, and it'd just be the tops of these histogram vertical bars. All right. So again, so the x-axis would be the midpoints. The y-axis is labeled with class frequency. I don't know why there's a T there. Right. So the y-axis is labeled with the frequency, just like it was for the histogram. In the last step, at each class midpoint, plot points at the height representing frequency for each class, and then you'll connect the dots. So questions on basically a line graph, also known as a frequency polygon. Misconception here is that people think we're going to be building these, because that's an example of a polygon, but this is not true. Okay. That's what I try to draw as a hexagon. All right, so again, here is your example. If I get my chart back out so I can see. So they started with the, I don't know why they started here. That's kind of interesting, but maybe that's where it needs to be. So if our first, oh no, right? Was that what they did? No, that's what they, okay. So they have here where we're adding up 90 every time. They went in and subtracted 90 more so that it could start at 0. It doesn't have to start at 0. So this part isn't something that you have to do. You could just start your graph up here if you wanted to, which is probably what I would recommend. And then notice that it hit 11 there, and then your 5, and then your 4s, and then the 0, and then the 1s. And then it went 90 more to show that it was 0 here. Again, these two things here are not necessarily needed. You could have just graphed it from here to here. But notice after you graph those points, you would then just connect the lines to make all these. Yes, you could technically start at 184.5 and end at 84.5, because the reader will also see that, all right, this is your start and stop. This must be your where your data is. Anything beyond that must represent 0, because it's not part of your data anyways. Because I really could have gone technical here, and I could have started at 4.5 and gone 0, 0, and then shot up. Right? Any questions on that one though? Pretty straightforward. A couple of things too. You still got to give it a name, and you still got to label your axis. So what's this axis going to be? And then what would this one be? Did I mess up? I guess. I don't know how to spell salaries. Give me a second. All right, what is it? This question? Yep. Oh, it's probably 6. Yeah, 634. Yeah. Good catch. 634. Any questions there? Any more errors? I like this. I did not create this. I used my resources that the book gave me that said I could use it. I got permission. You could technically do that. All right, so that's that. All right, so let's do this last one. Constructing an Ogive, which again is a commutative frequency distribution. So our line graph should now be increasing. So step 1, find the commutative frequency of each class, which we already did. So we're just going to fill it in. So this was 11, 16, 20, 24, 28, 28, 29, and 30. All right. So your line chart will look pretty much the same, except this time it'll increase over time. Does everyone have this written in? It is. It's just a new name for it. I don't know how recent it became a new name because I've never seen the word before in my life. So, and I just took statistics back in 22. So, well, that was granted, that was grad school. Ha 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 ha. No, 2022. Jokester, you. All right, step 2. Just like always, we want to label the X and Y axis. The x-axis again will be labeled with class boundaries, or sorry, not boundaries, midpoint. Man, I barely said boundary. I fixed it just like that. You're so quick. Yeah. So the x-axis is labeled with class midpoints. The y-axis is labeled with the scale appropriate for the commutative frequency. So would we want to use the same? I think it's how you spell it. Scale on the y-axis that we've been doing by going by twos? No, because why? We're going bigger numbers. We're going up to 30 this time. So what's a good scale? I'm thinking fives for sure. Like go 5, 10, 15, 20. And it's okay to change it from graph to graph as well. All right. And that last step there, at each upper class boundary, you're just going to plot the cumulative frequency points. Cumulative frequency points. Any questions there? All right. And I bet they graphed it for you already. And they did. Do what? And then that last step, though, it did say starting with the first upper class boundary, connect adjacent points with line segments. So here we go. Here is our Ogive, and you can see that it started with 11. It did go up by 5, which is a good idea. And then it went up to 16, which would have been your next one. And then what's the next numbers? Then it went up to 20. As you can see, it's hitting the line right there. The next one would have been 24, which is like right below it. And then we have 28 twice. Then 29 barely going up 1, and then 81.45 going up by just 1. So it looks like it's like linear, then gets a little less linear, and then a little more linear or whatever, which is fine. It doesn't have to look like a natural straight line. It can look like breaks, just depending on how big of a jump from one class to the next it is. But that is basically what an ogive is. Questions? So again, notice that they have a label. They then added it just so that the reader can see that this is an ogive, which they can know, all right, this is a commutative. If I wanted to know what this was, I would have to take this and subtract these differences to figure out how much it was in that category if I wanted to build maybe a frequency polygon myself off an ogive. Right? So do title it as an ogive at least. And then of course, yeah, so if I wanted if I wanted to know how much this was, I think this was a 24 and then this was 20. That tells me there were 4 people that had a midpoint of $454,000. But if you don't call it an ogive, then now it looks like, oh wow, there's 24 coaches out there making this midpoint range, and then and then this looks like it's more like 60 to 90 people inside this study. And then of course you still got to label your axis. So the y-axis would be, all right, but this one we're going to put cumulative frequency. Probably cumulative. I think I'm adding an N in it. I am. Gosh, cumulative. No, I just said it again. Say it again, Charlie. Cumulative. Say it again. Cumulative. Cumulative. I can't read right because that's not how you spell frequency either. Gonna add a Y there instead of an IY. And then this right here, of course, would be the all right. I still got a little bit more. We're almost done. Yeah. All right, everyone got that? Any questions on the three main graphs? All right. All right, so a relative frequency graph, this basically just uses the relative frequencies or appropriate scale instead of the frequencies. The graphs look the same, only the scale on the y-axis is different. So really what happens is it's like instead of it going by equal things, it's just we just know it is, and we're like ranging where it should fall. Like if it's like 11 versus like 30 without actual numbers, we can see that they'll roughly be twice as large or 3 times as large. Right? So that's what a relative frequency graph will look like. And really, you won't ever have to make those, but you have to be able to read those. All right. So then using histograms to describe the shape of distributions, although distributions are not often perfectly shaped, identify an overall pattern. So each thing we always look at always has some type of pattern. So let's look at these. So we have our first one, which is a bell shape. Can you give me any reason why I would call this a bell shape? It looks like a bell. So it kind of looks like this where it plateaus. When you hear of a bell curve, this is kind of that idea. These are your A's, or sorry, these are my bad. These are your C's. This would represent your C's in a bell curve, and then your B's, and then your A's, and then your D's, and then your F's. Right? Bell curve is designed. We cannot lower your grades, but a bell curve is to make sure that we have an appropriate amount of A, B, C's, D's, and F's in class. I don't believe in that. I think you should fight for everything you have. And if you all get an A, great. That just tells me the course is too easy. And then, so this is what will happen in college. Just to give you some ideas. A teacher gives you a test, you all pass with an A. Good job. Expect test 2 to be the hardest thing you've ever seen in your life because they got to balance that out. So they got to fail some of y'all. Some of y'all might, they might have the highest grade, they might be a C. And then the rest of y'all kind of fail or make a D. And then y'all kind of average back out. So then the third test will be an average between the two to kind of get y'all all to fall into these classes. You see this more in your first 2 years of college because all of your classes are what they call funnel classes. There's like 600 of y'all going into the class, and we only want about 400. And then the next one would be like 400, and we want about 150. And so then we just funnel you down. And then some of y'all like overlap and y'all go back into the same funnel to try to do it again. All right, uniform basically just means that it's pretty much leveled the entire time. There's not much left or right or bell or any kind of pattern. It's just pretty much flat across the board. J-shaped. That's what I was thinking. Well, no, because a J's made like this. Yeah. So this would be a J shape. This should have been called L shaped, but instead we're going to call it reverse J shape, also known as an L. But maybe. I don't see it, but that's a good stretch for it. I've actually heard this. Oh, good. It says it right below it as well. I've seen this as a right skew as well. Oh, I see. I see now. Okay, my bad. So okay, because that's what I usually see. Okay, so it's called J shape if it literally is going up with nothing coming back down. Reverse J shape again going down with nothing coming back up. So it's a perfect, it's almost like if you were to build a line graph here, it's a perfect positive slope of a frequency chart or frequency polygon. There's nothing like bouncing back up. But in a skew, there it is. So in a skew, you can see that there's an up and a down situation, but it's majority going to the. That seems backwards to me. And we were actually, what question that someone was talking? Charlie. Yeah, that's right. We were having this question. Yeah. So I guess the best way to look at this, right skewed would be where it's lower on the right, but where it's like pushing away from maybe, like it's pushing away from the right. Left skewed though, it's like this is pushing away from the left side. I don't know. Like I'm going up from the right, and here I'm going up from the left. That's good. I like that. Yeah. Earthquake happened on the right. Big tidal wave right here on the left. Big earthquake on the left. Tidal wave on the right. Big shoe looks good too. I like it. Yeah. So there you go. So there's your left and right. In my head, I would have that flipped. But it's where the data is going away from. Any questions on right and left? That's going to be a hard one. I used to have a sign up there that said right or left because I was tired of people asking me, where's my right, my left? Oh, all right. And then we have what? This is it? Okay. All right. So this is a bimodal. It's a bimodal because it's basically not a bell shaped. Bimodal. Have I told you I'm dyslexic? This is rough. That's a D. So we're gonna go with bimodal. It's almost like a bell shape, but it has two bell shapes. Okay, but a U shape has two high ends and it makes a U. Where this one's like it has a peak and then it has a nether peak and then it goes like there. By two multiple. Oh, I like that too. Okay. Bimodal makes an M. I like it. Modal. Yeah. The shape of the U. I like a valley. Yeah. This is what it looked like when it hit the Titanic right there. Valley. A V can be mistaken as a U. All right, and that's all I got for today.